Welcome back to the Edexcel Further Mechanics 1 video. Today we've got 6 examples to practice what we saw in the last video. In this question, we are first asked to convert 63 kilometers per hour into meters per second, and then find the magnitude of the momentum of a car with a mass and traveling at the same speed. For the first part, what we're going to do is we're going to write 63 kilometers, and we're going to change the per hour to divided by 1 hour, because that's what per hour means. So that's 63 kilometers divided by 1 hour. Now 63 kilometers is the same as 63,000 meters, because there are 1,000 meters in a kilometer. And 1 hour is the same as 1 times by 60 minutes. I can then go further and say that 1 hour is 60 minutes, which is also the same as 60 times 60 seconds. Now this is looking good because we've got meters on the numerator, we've got seconds on the denominator, so it's the right units. And it's simply a case of dividing these two numbers and seeing what we get. If we divide these two, we should get the correct answer of 17.5 meters per second. That's part A done. For part B, we are given the mass and we are given the speed. So all we need to know is that the formula for momentum is mass times by velocity, m times by v. However, we have to be careful because the mass has to be in kilograms and the velocity has to be in meters per second, otherwise we're a bit stuck. Luckily for us, we've converted 63 kilometers already, so we've just got to change the ton into the mass, which is 1,000 kilograms, and we already know from above that 17.5 meters per second is the speed. Once we time these two together, we get 17,500 Newton seconds as our final answer. In question 2, there's a golf ball of mass 0.4 kilograms and it's resting on a tee. It's then struck with an impulse and we need to find the speed immediately after it is hit. So in order to do this, we need to know the formula for impulse, which is mass times by speed afterwards minus speed before. So the impulse, we are told it's 20. The mass, we are told is 0.4. The velocity afterwards is what we're looking for. So I'm just going to leave that as v. And the velocity before is 0 because it's resting. It's not moving initially. With a little rearranging, we can find what v is. So in this case, we can times by 5, and then we can divide by 2, and we get that v, or the speed immediately after it is hit, is 50 meters per second. Now for part B, if the golf club is in contact with the ball for 0.2 seconds, we need to find the magnitude of the force acting on the ball when it is struck. We need to use our other formula for impulse here, F times t. So F is what we're looking for, and we know t is 0.2. I is still 20 from part A. This means that F over 5 is equal to 20, and therefore just one more line. The force is 100 newtons in total. In question 3, we've got a ball which hits a wall and it rebounds at a lower speed. We need to find the magnitude of the impulse exerted on the wall by the ball. For this one, I'd recommend a diagram. So I'll draw a diagram with the ball before it hits the wall and then with the ball after it's hit the wall. So in the question, it says that the speed beforehand is 2.5 and it said that the speed after is 1. And what I'm going to do is I'm going to define right being positive, because then we can get the impulse right. So u and v are going to be going in the same direction, and we're going to have to change them to negatives accordingly. Now impulse, the formula is m times by v minus u. M is given in the question, it's 0.3. And if we look at our arrow, v is going the other way around to the 1 arrow. That means that v is going to be -1, and then u is going in the same direction, so it's 2.5. That's probably the most common source of errors, is getting those negative signs wrong. So we've got 0.3 times -3.5, which should be -1.05. That's negative, but that's okay. We're looking for the magnitude of the impulse. So it's just going to be the positive version of this number. So the magnitude of the impulse is equal to 1.05. And we probably shouldn't forget our units, Newton seconds. We're halfway through now, so keep up the momentum. A bouncy ball in this question is being dropped from a height and then it is bounced on the ground. The magnitude is given and we need to find the speed of the ball after it hits the ground. So I'm going to draw another diagram, you know I am. It's going to hit the ground and it's going to bounce up. We know that 4 is the speed here, which is given in the question. And we know the impulse is 1.6. This time I'm going to define upwards as being positive, which means that v is already v, it's just the same, but u is going to be backwards. So u is going to be -4. Now we can write out our formula, still the same formula as before, it's not changing. So we know that 1.6 is equal to the mass, which is 250 grams, but remember we've got to convert it to kilograms, so 0.25. V is just v, and then u, as I said, is the opposite direction, so it's -4. This means that we get 1/4 times by v plus 4. If we times both sides by 4, we get 6.4 is equal to v plus 4. And then one more line, v is equal to 2.4 meters per second. In question 5, a ball is dropped from a height. Part A is using Suvat to find the speed of the particle before it reaches the ground. So no further mechanics in this first part. So I'm going to set up my Suvat equations by considering what's happening. Given that the ball is falling 1.5 meters, we can say that S is going to be equal to, in this case, -1.5 if I treat up as being positive. The u is 0 because it's dropped. It's not pushed with any speed, it's just dropped, so it's dropped from rest. And acceleration minus g minus 9.8 as usual. The equation we're going to use is v squared equals u squared plus 2as. And we can substitute in what we know. U squared is 0 squared. And this is 2 times a times s. So if I quickly type this into the calculator, I'll get v squared is equal to 29.4, which we can then square root to find v. Now, as the particle is travelling down, the velocity is actually negative. However, given the question just wants the speed, I'll leave it as the positive version. As this is an applied question, I should probably write that to 2 significant figures or 3 significant figures, but for now I'll leave it as a square root. In part B, the ball reaches 80% of its original height. So if it drops 1.5 meters, it reaches 80% of that height when bouncing back up. 80% of 1.5 is 1.2, and it's positive because upwards is positive. Its u is the speed as it leaves the ground, so that's what we're looking for, and v is 0 because it reaches its highest point and stops. A is still minus 9.8 as usual. We're going to use the same Suvat equation, and we're going to substitute the values in, and we'll see what we get when we rearrange. This time, we get u squared is 2 times 1.2 times 9.8, So u squared is 23.52, and when we can square root that to get the value of u, we find that u is equal to 14 root 3 over 5. Here the notation is a bit confusing. U is actually the starting speed of the particle when it goes upwards, but when we're considering the equation for momentum, m times v minus u, v is the final speed, which is the speed going upwards, and u is the speed initially, which is coming downwards. I'm still going to choose up as positive, which means that v is going to be exactly the same, 14 root 3 over 5, and u is going to be negative, so minus 7 root 15 over 5. And then all that's left to do is write down what I is, which we're told is equal to 10. Work out what the number, the very long decimal I imagine, in the bracket will be. And then divide to get what m is equal to. So if you type in those two surds, we'll get m times by 10.27 ... We're looking for m, so we'll rearrange for m, 10 divided by that new number. And we get the final answer of m, which is 0.97 ... which when rounded is 0.97 to two significant figures. You've made it this far, so one more question won't hurt. This time, two particles are going to hit each other. Once they hit, A travels at the same speed, but in the opposite direction. So for this one, I'm going to draw another diagram. We've got A traveling forwards towards B, and its speed is 1. We've got B traveling forwards to the left towards A, and its speed is 2. Afterwards, once they hit, they bounce back off each other. A travels towards the left, so it reverses direction. We don't know about B. We'll have to wait till the next part of this chapter to find out what happens to B. I'm going to quickly add the masses in here and just label them A on the left and B on the right. So we only have the velocities u and v for the particle A, so we can only consider the particle A when we do this equation. The mass of the particle A is 1. The speed afterwards, well, let's define a positive. I'm going to define positive to the right as usual. So that means that this end speed v is here and the start speed u is here. So v is going in the opposite direction, so again it's minus 1. We're going to minus, u is going in the same direction, so minus 1. So we get I is equal to minus 2. But we know that the magnitude of the impulse is going to be just 2, which is the final answer, 2 Newton seconds. Very well done if you've made it through all 6 questions. In the next video, we'll have a look at some past paper questions.